through the conditional probability with you, and you should be done at least to the end of 5.4 at the very least, and you should be on 5.5 and started it. But today we're going to look at 5.6. Today we're talking about independent events, so events in which you basically the same as very similar to mutually exclusive or disjoint sets. So events are independent when the probability of one does not depend on the probability of the other. For example, drawing a heart from a standard deck of 52 cards, replacing the card, and then drawing another heart from the same deck are independent events. Drawing an item and then drawing another item after replacing the first item results in a pair of independent events. The probability of that two independent events, A and B, will both occur is the product of their probabilities. Okay. So last week we talked about probability of A and B. Is the probability of A of the probability of B, given that we already know what A is. This is what we refer to as a conditional event. So when I looked at, I believe I did 7 blue and 4 red bracelets, and I asked you, okay, what is the probability of picking 2 blue bracelets? All right, so we set up our tree diagram. We had 7 out of 11, 4 out of 11, blue, red, 6 out of 10, 4 out of 10, blue, red, and that one would have been 7 out of 10 and 3 out of 10. Okay, so the probability of picking blue is 7 out of 11, and then what's the probability of another blue given that we already picked the first blue? 6 out of 10, and we multiply them together, we end up with 42 out of 110. Okay? So that event was conditional on what happened to begin with, because that changed my probabilities. Today, we're saying the probability of the second event doesn't have any, or sorry, the probability of the first event doesn't have any bearing on the probability of the second event. So what does that mean? Well, if I did this same experiment and I replaced the first bracelet, okay, then what would happen is, what would be the probability of 2 blues then? Well, the probability of getting a blue on the first was 7 out of 11, right? And what's the probability of the second if I replace it? It's 7 out of 11 again.
So that means like if you pick the blue and then threw it back in?
Yes.
Okay.
This means that these would be independent events in which I'd have 49 out of 121. Okay? So these are independent events. Alan rolls 2 4-sided dice and tosses 1 coin. Determine the probability that the product of the dice is an odd number and the coin lands on tails. Okay? So we want the product that it's an odd number and we get a tails on on the coin. All right. So it gives you all of the products. So how many of those products are odd? They've shaded them for you. 4 out of how many scenarios do we have? 16. So I have 4 out of a 16 on this times, what's the probability of getting tails on the flip of a coin?
1 out of 2.
1 out of 2. One out of 8 chance that that happens. Okay. All right. So this is easier than what we did on Thursday and Friday on that conditional probability, because the events are independent of each other. So all you do is multiply the 2 events together. All right.
So it's basically the same, just now it's 2 events that are different, you just get them multiplied.
Mm-hmm. That's right. Okay. You have today to work on 5.5 and 5.6 and get through those. All right. We had all day on Friday. We just had a work day basically. So that was to get you through 5.3 and 5.4. Were there any questions from Friday? I should ask that first. Did we have anything circled from Friday that we weren't able to get?
Number 1C,
What page?
134. I knew what,
Hector rolls 2 standard dice, 1 red and 1 blue. He divides the number on the red die by the number on the blue die.
What?
You can move.
Oh, never mind.
You can move if the quotient is either a whole number or a terminating decimal.
I did the chart right, but I keep putting the wrong answer.
He divides the number on the red die by the number on the blue die. So I take this number and I divide it by that. Right?
Right.
1 divided by 1. 2 divided by 1. 3 divided by 1. 4 divided by 1. 5 divided by 1. Those are all whole numbers. Agreed?
Mm-hmm.
1 divided by 2, half. 2 divided by 2, those are all whole numbers or terminating decimals.
I did it backwards. I took the other side and divided by the top
We
side.
should still get the same answer because you're using 6 and 6. Now, when I divide this 1 by 3, is that a terminating decimal?
1/3. No, it is not. It's 0.333.
Right.
That's not
2/3?
2/3 is the same way too. It's
Right.
still repeating.
3 divided by 3 gives me 1. That's not, these are non-terminating decimals, and that's 2. So there's what I got so far. So far that is all the whole numbers or terminating decimals.
I don't know what I did, but some of these answers are not what I see on the board. Or let me,
1 divided by 4, quarter, a half, 3/4, 1, 5/4. What's that, 3/2? All of those are terminating. All of these ones are terminating.
What does terminating mean? Yeah,
Stops and doesn't go forever.
so like 1/3 wouldn't be terminating?
Yeah.
Because that's repeating,
It's repeating.
so it wouldn't be.
So far, all my terminating decimals are right there, and my whole numbers. You following this so far?
yeah, I know what terminating decimals and the whole numbers, but I don't know, I must have did my math wrong because my chart's a little off. The 4 section I did it right. That's for 5. 1/5 as decimal 0.2, right?
Mm-hmm.
So I'm pretty sure doing that row right. I know which row I messed up on.
6 now. 1/6 is not terminating. It's a repeating. 2/6 is repeating. 3/6 is 1/2. That's terminating. 4/6 is not. 5/6 is not. 6/6 is 1.
Why would you keep 5/5 as 5/5?
No, it doesn't matter. Right there is all of the possibilities to have a terminating decimal. Or a whole number. So count those up and how many you have of those out of 36 is your answer.
I'm counting in my head.
2 in this row, plus 6 here is 8, plus 6 here is 14, 16, 22, 28. Your answer is 28 out of 36.
There's no easier way to do that. You have to make sure.
Wow.
I said for some reason go 23. So there's something I either,
I'm guessing that you didn't include the thirds and the 3 divided by 3, 6 divided by 3, 3 divided by 6, and 1 over 6. I would say that you're missing those 4 for sure.
Yeah.
Is there an easier way? Not really, no. Unless you just, you know that all of the anything you divide by 1 is going to give you a whole number. Anything you divide by 2 is going to give you a terminating decimal.
So you basically have to look for the all one. You will not even make the 6. Divided by 6 also.
The easiest way to do this question would be to find the actual repeating ones and then subtract it from 36. That would be the easiest way.
Okay, never mind.
Okay, Morgan, you, just let me finish with Morgan here. You got that?
I understand, I'm good, I just may have made some simple mistakes on, my chart here. As far as I know, I've divided them all right, 6, 5, 4, it's all correct. It's just I got mixed up on what was right and what was wrong.
Okay. Is there anything else?
Can we do number 3 on the same page?
Selena is about to draw a card at random from a standard deck of 52 playing cards. If he draws a face card or a red card, he'll win a point. And watch you do a Venn diagram. Here's your face cards, here's your red cards. I'm going to start in the middle. How many red face cards do I have?
26.
Red face cards.
I have here. 3 face cards. Right. 6 face cards. 6 red face cards.
Right. So you got Jack, Queen, King of the diamonds, hearts, diamonds, hearts, diamonds, hearts, right?
Right.
Now I have face cards, you've got Jack, Queen, King, spades, clubs, spades, clubs, spades, clubs, right?
Right.
So there's 6 there, correct?
Yeah.
And then over here I've got the rest of the red cards. So that's your hearts. So that'd be 10 of those. Right?
Right.
And then I have 10 diamonds.
I didn't do it that way. I did it a different way.
And then what's out here?
What remains? Spades and clubs.
So 10 spades and 10 clubs. Right?
Right.
Because those still are included, those face cards are still included here. So it says, if he draws a face card or a red card, he'll win a point. So draw a Venn diagram to represent the 2 events. Are the events mutually exclusive? Are they mutually exclusive?
Mm,
Do they have a disjoint set?
no.
No. They share the red face cards. So they're not mutually exclusive. Okay?
Okay.
Determine the probability of drawing a face card or a red card. So, 6 and 6 make 12, 22, 32. There's your answer.
Okay, nothing in common, they're not mutually exclusive.
They are.
They are mutually exclusive, but they have nothing in common.
Exclusive means that you have separation, right? Like they're not together. Right. So then if they have nothing in common, they are mutually exclusive. Okay, ready to question?
Yeah. So diamonds and hearts in each set or whatever, those will be the red cards in each set?
Mhm.
Okay, I didn't know
26 red, 26 black.
that. Yeah, I knew that, but I didn't know that it was like specific to diamonds and hearts were red.
It is. Morgan, questions about that guy?
The way I did it was completely backwards or not backwards, but off to what you did there. Forget
When
what
you're
I
doing
did.
Venn diagrams, Morgan, you start in the middle all the time. What's the same? That's where you start.
Yeah.
Okay.
That's for face cards and that's for red face cards. So I knew that there were 6 cards. So I did that part right, but the other 2 parts, I don't know, like I must have read the instructions wrong or because I just put I think I put all the red and then I put all the face cards in the other bubble, I didn't have anything there. I
This
took the
Kendrick
empty
call
key,
50,000, please. This
and
Kendrick call 50,000.
I knew that there was something not right.
You see how it works?
So the red bubble is what remains without the face cards,
That's right.
and what remains of the face cards, like the spades and clubs, and then whatever. Okay, I understand it better now.
Okay.
But I read the question wrong and didn't do it that way.
Anybody else have any questions from 5455? Go ahead, CJ.
On 137, number 2, and like number 1, I guess, like, why, like, the first one's independent and the second one's dependent? Like, question 1's independent and question 2 is dependent? Like,
Mhm.
why are they, like, what's the-
Because in the second one, you're not replacing it. So you have less outcomes
So,
after your first event has happened. Okay, so let's go back to my blue and red question here. All right, so if I replace, if I take a blue out, but I put it back, my probability stays the same. Okay? So they're independent of each other. So let me explain using this guy. If I take one out and I don't replace it, now my number of outcomes are different. That means that this is dependent on what happens here.
okay.
Is that better?
If you don't replace it, it's dependent.
That's
If
right.
the second event,
Has different outcomes than the first event because you took one thing out on your selection.
dependent?
That's dependent. And independent is if you replace. Okay, anybody else have anything they want to ask today? Okay. You're probably looking at a test at the end of the week, would be my guess. We're 356 today, so we'll see how it goes tomorrow, and then we've got 2 days to review, so your pre-test would come Wednesday. We'll go from there, okay?
We're not here.
It's Wednesday after.
We have both girls and boys teams have zones on Thursday.